hydrogen gas is kept in a tube at very low pressure and electricity is passed through it. Spectral analysis of the emitted radiation showed a line spectrum with about 3 distinct visible lines. Now, what actually was happening here? When the hydrogen gas was excited by creating a potential difference in the tube containing the hydrogen gas at low pressure, the lone electron was lifted to higher energy level. Now this electron at higher energy level will come back to the lower energy level when everything cools down. In doing so, it will emit a radiation of wavelength lambda given by the equation delta E equal to hc divided by lambda, where delta E is the difference in energy of the level from where the electron is dropping to where it is actually dropping. H is the Planck's constant and c the velocity of light. Now, when the electron drops back to the lowest level, where n equal to 1, the wavelength is approximately from 90 nanometers to 120 nanometers. This falls in the UV range of the spectrum and is called the Lyman series. When the electron drops back to n equal to 2, the wavelength varies from approximately 371 nanometers to 656 nanometers, which lies on the visible region of the spectrum, and this accounts for the visible lines in the hydrogen spectrum and is called the Bohrs series. When the electron drops back to n equal to 3, the wavelength is approximately from 850 nanometers to 1875 nanometers, which falls in the IR region of the spectrum and is called the Paschen series. There are 2 more series, namely bracket and P-Fund series, when the electron drops back to n equal to 4 and n equal to 5 respectively. Both of them fall in the IR region. Thus, the line spectrum for hydrogen atom was established. Bohr suggested that only those orbits are possible where the circumference 2 pi r is an integral multiple of the wavelength lambda, where lambda is given by the de Broglie equation lambda equal to h by p, where p equal to mv. Therefore, lambda equal to h divided by mv. Now, as per Bohr's suggestion, 2 pi r equal to n lambda, or 2 pi r equal to nh by mv, that is mvr, which is the angular momentum, is equal to nh by 2 pi. From this, he calculated the radius of the nth energy level of the single electron species like hydrogen, He plus, Li2 plus, etc., and established the formula Rn equal to 52.9 n squared divided by Z picometers, where Z is the atomic number and n is the energy level. Energy of an electron of the nth energy level in all hydrogen-like species was also established as follows.